Hi again. Today we're looking at inverse functions. Um, your inverse functions. Well, first of all, let's go ahead and then remind ourselves a little bit about what a function is. A function is simply a rule that takes a set of values or numbers and then tells you what to do with those numbers. So in its most basic sense, if I have a function f of x and I apply the numbers 0, 1, or 2 those into that function would tell me what numbers I will get. So I happen to know what the answers are. If I plug in 0 into this function, I will get the answer 1. If I plug in 1 into this function, I get the answer 4. If I plug in 2 into this function, I get the answer 7. Now, so, who knows, but this is what our function does. The initial set of values that we use, we call those numbers the domain. The resulting numbers we get, we call the range. Now, don't know why they're called domain and range, but domain are your inputs, your range are your outputs. The inverse function right here is the function that does everything that this function does, but does it in reverse. And so the first things first is the notation. We go f negative 1 of x. This is read f inverse of x. And what the inverse function does is that it does the reverse of the original function. So right here, if I take the number 1 and I plug it into the inverse function, the result I will get is 0. If I take the number 4 and I plug it into the inverse function, the result I will get is 1. If I pick the number 7 and I plug that into the inverse function, I will get the answer of 2. So, there are some key things to remember about the inverse functions. First things first is that the domain and the range switch places. The domain of the inverse function is the range of your original function. Again, the two functions are very closely knit, and so we use the same letter to represent them. We try to indicate that they're coming from the same place. It's just that one is doing the reverse of the other. So first things first, the domain and range switch places. The second thing is you can think of the inverse function as doing the opposite of f of x. Or the reverse. I actually sometimes call it the reverse function. Not inverse, reverse, get it? The other thing that the inverse function does is that it switches the x and y values. So right here, my x is 0, my y becomes 0. My x is 1, my y is 1, now my x is 1. And so it has that ability of switching your x and y values. Again, the last thing it does is that it switches the domain and range. I need to think of that for a second. If I'm switching all of the x and y values, that means I am switching the domain and range. So, with that being said right here, if I go back for a second and be honest for just a second right here, my original function right here is actually 3x plus 1. If I take 0 and I plug it in, I get an answer of 1. If I plug 1 and I plug it in, I get an answer of 4, so forth and so on. And so the question is, well, what's the form factor for the inverse function? How do I find that equation? Alright, we'll do that right here in several stages. We'll start out with simple and then work our way up. So the question is finding that inverse. Let's start the simplest situation right here. Let's say I have a function f of x and I just simply give you ordered pairs from that function. So when I plug in 0, I get an answer of 1. I plug in 1 and I get an answer of 4. When I plug in 2, I get an answer of 7. When I plug in 3 and I get an answer of 10. So these right here are ordered pairs from the function. To describe the inverse function right here, all I have to do is switch the x and y values. So the first ordered pair becomes 1, 0, and so forth and so on. Notice that we do not switch the signs. Notice all we're doing is we are switching the x and y values. This function, therefore, is doing the reverse of the original function. That's it. The nice thing here is that if you understand this, if I were to give you the graph of a function and ask you to find the inverse, you'll note that you have to do exactly the same thing. So let's say I have a function right here and right here, and the graph of my function looks something like this. Well, it is a function, therefore it must have some kind of ordered pairs. So let's take this first point right here to be -4, -4. So that's this point right here. Then this point right here might be -3, 0. Then this point up here might be 0, 3. And then let's take one more point over here. Let's take that point to be 4, let's say 4, 5 for argument's sake. Again, this is not drawn to scale. So you have right here, you have your point 4, 5. Well, if I want to graph the inverse of this function right here, all I do is I simply make a simple table of values for my original function. Let's give it a name, f of x. Oops, I missed. And y. And so this right here is my function f of x. And so my x coordinates are -1. My coordinates are -4, -4, -3, 0, 0, 3, and 4, 5. Well, the ordered pairs for the inverse function would be basically the same value, but just like we did before, simply need to switch the x and y values. Comprende? Simply plot those points, and that will give me the graph of the function. All we're doing is switching the x and y values. If I switch the x and y values here, I will obviously end up at the same point. Then the next point would be 0, -3, which would be down here. Then the next point would be 3, 0, which would be over here. And then the last point would be 5, 4, which would be over here. And then when I connect those with a smooth curve, that gives me the graph of the function f inverse of x. The last thing that I need to point out is that, interestingly enough, if I was to draw the line right here, a 45-degree line right here, which is the line y is equals to x, this line should, in theory, cut this graph exactly in half. And the line y equals x, whenever you reflect in the line y equals x, it has the effect of simply switching the x and y coordinates. And so if you wanted to, I guess, make this a little bit better right here, the graph. And so if you want to graph the inverse by eye, all you need to do is just flip the graph over that line, y equals x, and that right here takes you to the graph of your function.